Hello guys, welcome back to Simpson Strong Ties CFS Designer video tutorials. In this video tutorial, we will go through a header jo header beam. Uh, so in the last video tutorial, we applied uniform loads, but this time we'll apply point and sloped loads. So as you can see, let me just this is my project manager tab. In this tab I can save all my different types of beams. So I'll just select this one. I'll say duplicate so that it will create a duplicate for me, and let me say uh, point and sloped loading. So since you should have some idea about light gauge, over here we can select our member, but before doing that, what I'll do is I'll select first. Okay, alright, so coming over here, I'll select my beam joist, so it will be header beam, and my load modifiers will be over there. I'll remove the uniform load that I had over there, and my span will be, let's say, 12 feet. That will be 0, no load. Alright, so okay, I had a built-up section in there, so let me just go ahead and remove that. We'll go through the built-up section in another video tutorial. Just in case whenever the load is very high, so you might need to go through a built-up section. So now I'll just select my, oh my god, alright, I'll just go and select over here boxed. I need to make sure that if it was built up, I need to make sure that I'm in this tab and I change it. So I'll select boxed, and I'll make sure that this is beam joist. My load modifiers, I have a span over here 12 feet, and over here I'll go to point loads. I'll say I have one point load, and I'll say it is 2 kips, nothing but 2000 pounds at a distance of 6 feet. That should be fine. Okay, now I'll go for a sloped load. So I'll say this is starting from 1000 pounds per feet to 1200 pounds per feet, starting from 3 to 9 feet. Okay, so this looks good, and let me just reduce this to 1000 pounds instead. Since this is just for representation purposes, like how to apply loads and stuff. Whenever you're doing a real beam, you will have some loads, you will apply those loads over here. Anyways, so as you can see, I'll just select this member summary. As you can see, my members are stressed out 147.8%, which should be less than 100%. even this should be less than 100. So I'll go in there, I'll try to select 1200, I'll select 97 grade, and as you can see the maximum member stress got decreased to 76.8 percentage. Let me try it with 1000. Yeah, it's still passing, but it's barely passing, so there might be some loads which are unexpected, so it would be better to go with 1200. So now what we'll do is we'll go to the diagrams tab, and we can see the deflection which is less than 1 inch, which is 1.168 inch, which is very nice. I mean, you are safe. Next, going to the moment, you can see the moment diagram for a simply supported beam, nothing but. And then alright, next you can see your shear and also find out your reactions. So guys, you know the deflected shape, and you can see the maximum and minimum, even in moment, maximum moment and minimum moment. So guys, that is the way you do for point and slope loads. And let me try something new for you guys. So as you can see, in model and uniform loads, you entered your span, and let's say you have a left cantilever of, I'll say, 2 feet, with a uniform load of 20 pounds per feet, and we'll have the flexural bracing at midpoint. So you can still see that the member is passing, but now if you see the deflection, it might have changed. As you see, the deflection is 14.147 inches, and similarly you go for shear, you will find it different, the shear drawing, even the moment drawing. Alright guys, thank you for watching the video. Please subscribe. If you have any questions, please comment below.